Hello students, my name is Sanjay Jain and in today's lecture we will discuss about sum of arithmetic progressions. In the last lecture we discussed about a few terms of AP. For example, we discussed about first term, common difference and then nth term of an AP, right? We discussed that the first term was A, second was A plus D, third term was A plus 2D, and similarly we reached at a conclusion that the nth term was A plus n minus 1 into D. So this was the nth term which we denoted by an, right? And we did a lot of questions based on nth term. So in today's lecture what we will do is we will take the sum of first n terms of an AP, right? So we will denote sum of n terms of an AP by Sn, right? Sum of first n terms of an AP. Okay, so Sn will be equal to A1 plus A2 plus A3 plus up to an minus 1 plus an. So this is the sum of first n terms of an AP, right? If you could notice, if this is the sum of n terms of an AP, what will be this sum equal to, right? This sum will be equal to S of n minus 1, right? It is pretty obvious that this sum is sum of n minus 1 terms of an AP, right? So now if I see an will be equal to what? Sn minus 1, right? This is an important relationship between nth term of an AP and sum up to n terms, right? So nth term of an AP will be Sn minus 1. This is a very useful relationship which we will see in the upcoming questions, right? So let us first of all calculate sum of n terms of an AP. Sn, it is equal to A. Let us first of all write it in A1 plus A2 plus A3 plus an, right? Now what did we learn about A1, A2, A3? That let us consider A1 equal to A, first term is A, and common difference we take as D. So the next term A2 will become A plus D, A3 will be A plus 2D, right? And so on up to an. An will become A plus n minus 1 into D, right? So we need to find this sum. Okay. Now to find this sum, I'll tell you one trick. If I write this sum other way round, it won't make any difference to this expression, right? A plus n minus 1 into D. What was the second last term before this A plus n minus 1 into D? It was A n minus 1, right? Which is equal to A plus n minus 2 into D, right? So the next term will be A plus n minus 2 into D and so on. In the end we will write A plus D and A, right? I have not changed this expression, I have just written this expression other way round, right? I have just flipped this expression. So now this Sn and this Sn are the same thing, right? So if I now add first term of this expression with first term of this expression, what it will give me? It will give me this sum, right? If I add these two equations, it will give me twice of Sn equal to, what is the sum of first terms of both these expressions? 2a plus n minus 1 into d. Now if you notice carefully, sum of second terms of both the expression will be a plus d from here and this from here. If you add these two expressions, it will again give you 2a plus n minus 1 into d, right? You can add these two, a plus a will become 2a, n minus 2d and 1d will become n minus 1d, right? So this again gives me 2a plus n minus 1 into d. And this will happen for each and every corresponding term. For the last term, you can see it will again give you 2a plus n minus 1 into d, right? Because when you go towards right in this expression, first expression, a d will be added to each and every term, right? And in this expression, when you move towards right, a d is getting subtracted from each expression, right? When you take this sum, it will adjust the d, and sum will be same for the corresponding terms, and it will be equal to 2a plus n minus 1 into d. And how many times it is written 2a plus n minus 1 into d? Obviously n times, because there were n terms in this expression, right? Similarly, n terms in this expression. So in this sum, there will be n terms. So twice of Sn will be equal to n into 2a plus n minus 1 into d, right? So we can say that sum of n terms is equal to n by 2 2a plus n minus 1 into d. Okay, so this is the sum of n terms of an AP, where a is the first term of the AP, d is common difference, and n is the number of terms of the AP. So if I write S11, it will mean sum of first 11 terms of the AP, of an AP. Okay, so this is the formula for sum of n terms. Now if I break this formula, Sn equal to n by 2, if I write this as a plus n minus 1 into d. Now do you recognize this expression? This was the expression for the nth term, so I can write it as an. So the sum of n terms is also equal to n by 2 a plus nth term, which is sometimes referred to as last term. So I can write it as L also. So it will be equal to n by 2 a plus L, right? Where n is the number of terms and L is the nth term or the last term, right? So if you have got first term and last term of the expression and number of terms, you can directly calculate the sum of n terms, right? So till now what we have learnt is that sum of n terms of an AP is equal to n by 2 2a plus n minus 1 into d, and it is also equal to n by 2 a plus L, where L is the last term of the AP, right? So now let us see some of the applications of sum of n terms of an AP. If I want to calculate sum of, let's say, natural numbers, if I calculate sum of first 100 natural numbers, let's say up to 100, right? One of the way to think about it can be that I can flip this expression and write it as 100 plus 99 plus 98 plus and so on up till 1, right? I have just flipped this expression, I have not changed even a single term here. So both these expressions are same. Now if I add these two expressions, twice of Sn will be equal to 101 plus 101 plus 101 plus 101. How many times? 100 times. So it is equal to 100 times 101, right? So Sn will be equal to 100 into 101 by 2, which is equal to 5050, right? This is the same algorithm that we took while proving the formula for Sn, right? We can derive a formula for this also directly. Sn equal to, let us say we take 1 plus 2 plus 3 plus up to n natural numbers, right? So if I want to derive the formula for this, I just need to flip these numbers, okay, and now I add the corresponding terms. I will get n plus 1 every time, and how many times? N times, right? So Sn will be equal to n plus 1 by 2, right? We have divided by 2 because it will be the sum of these two expressions, which will give me 2Sn, and 2Sn equal to n into n plus 1. So Sn will be equal to n into n plus 1 by 2. So sum of first n natural numbers is equal to sum of first n natural numbers is equal to n into n plus 1 by 2, right? This is an important formula that you need to memorize. We can also find sum of first n odd natural numbers. This will also be useful while solving the questions. Sum of first n odd natural numbers will be 1 plus 3 plus 5 plus 7 plus, what will be the nth term? What will be the nth term? Nth term here will be 2n minus 1, right? Because if you put n equal to 1 here, it will give you 1. If you put n equal to 2 here, it will give you 3. So the nth term of this AP will be 2n minus 1. Otherwise, you know the formula for nth term. What is the formula? A plus n minus 1 into d, right? So an will be equal to, what is a? 1 plus n minus 1. What is d here? Common difference 2, right? 1 plus 2n minus 2, which will be equal to 2n minus 1, right? So sum of first n odd natural numbers will be sum of this AP, right? Let's apply the formula for Sn here, right? How many terms are there? N terms. So n by 2. Twice of first term is 1 plus n minus 1. What is the common difference? Common difference is 2, right? So it will become n by 2. 2 plus, if I multiply this 2 in this bracket, 2n minus 2. So this 2 gets cancelled. N by 2 into 2n will give me n square. So sum of first n odd natural numbers is equal to n square, right? This is another formula that I want you to memorize here, because it will make your life very simple while solving questions. So we have found sum of first n odd natural numbers, which is equal to n square. Now we can easily find sum of first n even natural numbers. First n even natural numbers. If you notice here, if I add 1 to every term of this AP, if I add 1 in this, it will give me 2. If I add 1 here, it will give me 4. If I add 1 here, it will give me 6, and so on. So I will get all the even natural numbers by adding 1 to the every term of this AP, right? That means, how many times do I add 1 in this? N times. Obviously n terms are there, so I add 1, 1, 1 n times, right? So if I add n in sum of odd natural numbers, it will give me sum of first n even natural numbers, which will be equal to n into n plus 1. Let me explain it one more time. What was the first n odd natural numbers? 1 plus 3 plus 5 plus 7 plus up to 2n minus 1, right? Now I want to calculate sum of first n even natural numbers, which will be 2 plus 4 plus 6 plus 8 plus up to nth even natural number will be 2n, right? How do I go from this AP to this AP? By adding 1 in every term, right? What was this sum? This was n square, right? And how do I obtain this sum? Next, this one, by adding 1 to each term. How many times do I add 1? N times. So I can add n in this directly. It will give me n into n plus 1, right? So sum of first n natural numbers in AP was n by 2, 2a plus n minus 1 into d, right? We can also write it as n by 2, a plus L, where L is last term, right? Sum of first n natural numbers is equal to n into n plus 1 by 2, right? Sum of first n odd natural numbers was equal to n square, and sum of first n even natural numbers is equal to n into n plus 1, right? These are important formula. You can memorize these formula, or you can directly derive it there and then and there, right?
Now, subscribe to Bright Tutee course at ₹1 per day only. Download Bright Tutee app from Play Store and get the online courses prepared by competent and experienced teachers for different education boards of classes 6 to 10. Bright Tutee courses are available for the subjects of Math, Science, Social Science, English and Hindi in English and Hindi medium. Bright Tutee follows 3-step approach, that is learning, assessment and exam preparation. In learning, topic-wise video lectures with explanation of concepts and discussion of textbook examples and questions are available with the solutions. In assessment, topic-wise online MCQ test, practice assignments and chapter-wise question bank are available with the solutions. In exam preparation, previous year's question papers, sample papers and model test papers are available with the solutions. Sign up today on Bright Tutee and avail your courses at affordable prices.